Happy Thursday, everyone. I'm Chris Brewer, Customer Development Manager for Lean Scheduling International. We're so glad that you're taking time out of your busy schedules to join us today for this webinar, which is Advanced Planning and Scheduling for the Plastics Industry. We're set for 1 hour today where we're going to walk through Opcenter APS. It's formerly known as Preactor Advanced Planning and Scheduling. And what we're going to do, we're going to show you solutions to those common planning and scheduling headaches that you all face in plastics manufacturing. I'm going to be your moderator. And we're going to pause periodically to give you the opportunity to ask questions, and you can do that by using the Q&A button at the bottom of your screen or by sending a message through the chat window. Alongside me today is Hans Albright and Fraser Bonnet. Hans has a wealth of real-world manufacturing and consulting experience. With 30 years of experience in manufacturing systems, he spent the last 20 years selling and implementing APS and ERP solutions. He now serves as our Vice President of Sales and Marketing here at LSI. And there's a good chance that Fraser Bonnet has more experience with Opcenter APS than anyone in North America. After he served 10 years in the United States Air Force as a program manager, he worked a number of years with the SCADA software at Raytheon, but he spent the last 23 years delivering Opcenter APS. To make sure that we make good use of our time today, I'm going to be quiet and turn this over to Hans. Hans, it's all yours, my friend.
All right. Thanks, Chris. I just want to confirm that you can hear me.
Yes. Absolutely. Yep.
Okay. And Chris, by the way, I just wanted to ask, we are recording, is that correct?
That's correct. Yes. This will be available for everyone after the webinar today.
Excellent. Okay. Thank you. All right, everybody. Well, let's get started. So I wanted to start today with the agenda that we put together. So what I'm going to do is I'm going to run through some slides. In those slides, I'm going to introduce you to Opcenter APS, to our company, LSI, Lean Scheduling International. We'll talk a bit about the plastic industry scheduling challenges, and then we're going to get into the software. The plan for what we're going to demonstrate today, Fraser will be starting out. He's going to go into some basics, introduce you to the product, and then go a little deeper and start talking about some other things like advanced scheduling rules and sequencing for colors, materials. Sequencing using temperature requirements can be very tricky. And also, then I will be sharing some stuff about mold frames and mold frame groups. And then we'll be taking questions. However, we will finish with the Q&A period, but I just want to be clear that we will stop a few times, as Chris mentioned. So please get those questions of yours into the chat window and pass those on to Chris. And at the appropriate breaks, if we've got anything coming in, we'll answer those questions. So let's get started. So the current trends and challenges in plastics, I mean, there's a lot of stuff going on that just makes it a lot harder, a lot trickier for you to do your work, a lot of changes that are going on. Foreign competition have a huge competitive advantage in the way of cheaper labor, materials, fewer regulations to deal with. And people are demanding different products. People don't want unsustainable products any longer. They more and more there's a demand for maintaining sustainability. And people are shopping differently, which changes the demand, what the demand looks like coming through as people, do more e-commerce, packaging requirements are changing. All of those things come together, along with issues with workforce, labor. How about unforeseen events like COVID-19? I mean, my gosh, that knocked a lot of us off our feet when that came along, and we weren't prepared for that. And overall volatility in the supply chain these are all things that you have to deal with on a regular basis, and they all affect scheduling in some way. They increase the complexity of your work. And the bottom line is that mistakes and problems in such a hard competitive environment can be very consequential. So that brings us to our topic today, which is APS, or Advanced Planning and Scheduling, and how can an advanced planning and scheduling tool help you overcome a lot of these challenges that you deal with. So to start with, I'm just going to start with this statement that APS is going to help you optimize the things that define value for your company. Now, I'm not a fan of business lingo and buzzwords, but another way of talking about this is value drivers. Optimize your value drivers. But I'd rather say it this way, the things that define the value for your company. So, for instance, quality, right? You want to put out a quality product. You want to be known for having a quality product. You have all of this expensive equipment, your facilities, all of that, your assets. You want to be sure that you're using them to the best of your ability to use them and get the most out of them. Time to market. Your competitors, they're doing the same thing. So it's a race to get things to market and get that market share as quickly as you can. Your labor, your employees, your most valuable asset that you have. You want to be sure that they're taken care of, but you also want to be sure that they're productive. And so you want a tool that's going to help you be sure that that happens. And then inventories, whether it's finished good, raw material, work in process. You want to be sure that you have the right level of inventories, and you want to be sure that those inventories are available when you need them and where you need them. So how does APS help with these kinds of things? I mean, APS is just scheduling, right? I mean, what does that come down to? So this is kind of a high level list, but resource allocation and tool utilization increase. So this is going to help you get the most out of the resources that you have available. How about bottleneck? How often in your plant do you discover that you've got a bottleneck where all of your work is just hitting a point and backing up? And it can create chaos. I mean, it can be a real mess. So why not have a tool that helps you spot those bottlenecks before you even go into production so that you can alleviate that and everything goes through smoothly, increasing your throughput. Fast and frequent rescheduling, my gosh, I mean, that can come from customers, it can come from unexpected events during production in the plant floor. You need to be able to react quickly. You don't want to have to do 4 hours, 5 hours of work to deal with one order change. You want to be able to do it in seconds and move on and keep going without interruption. Work in process reduction and raw material inventory reduction. But again, emphasizing you want to keep the lowest levels of your inventory that you possibly can, but you want to be able to also have the inventory that you need available to you when you need it and where you need it. That's critical. So you want a tool that is going to help you do all of these things. And when you have that tool and you are realizing these types of benefits, this is what you see. You see improved communication and not just internal communication, but communication with your customers and your suppliers. Improved customer service. I mean, I don't have to say much about that. You know the value of that. And overall improved productivity, which is, again, getting the most out of the investment that you've made for all of those things that define value for you. And what's the bottom line of all this? It's going to be increased profitability. So that's why APS is a smart idea to help you get to that increased profitability and take advantage of the assets that you have and make the best of them. So APS, and specifically now, we're going to talk about Opcenter APS, formerly Preactor. So on the left-hand side, you can see I'm talking about Opcenter APS. It's a product that has been around a long time, well over 25 years, and it has the largest install base of any standalone APS system worldwide. You can see the numbers there, over 6,500 companies use it, over 10,000 licenses shipped. And in North America alone, nearly 350 companies have purchased, or probably over that by now, over 350 companies have purchased Opcenter APS in North America. Looking to the center, you see all of these logos that I have. And these are all customers, all people who use APS. And of course, there are many, many, many more than that, but these are ones that are probably recognizable to you. And it's good to point out, too, the different types of industries that they all come from. And you can see that multiple different industries, something for food and beverage, but also automotive and industrials, pharmaceuticals. That is a testament to the flexibility of Opcenter APS, that it is a configurable product that can get the results that you need specifically to your organization, not just your industry, but to your organization. So on the right-hand side, then, is images that show what Opcenter APS is comprised of. And it's two things. Visual finite scheduling, that's where our effort is going to be today, primarily, and visual long-term planning. So I'm going to just do a real quick, one quick slide on the planning that I'll talk about in a couple of minutes. And that's all we're going to do. But again, I want to emphasize on the planning. If there's any interest in learning more about that, please contact me, because I can get some information to you. I can get you set up with a demo. We can do a lot there if it sounds like it would be something that's interesting for you. It's especially helpful for people who do a lot of commodity buying. If you have multiple facilities, you need to balance capacity between facilities and basically do long-term forecasting and planning. This is a tool that will help you get there. If you're doing forecasting, this is a tool that will help you get to the long-term planning. Okay, and then at the bottom, Lean Scheduling International. We have been around over 25 years and have 80% of all of the Opcenter APS installs in North America. So from a skill standpoint, we have the most skilled engineers and consultants in the industry who all work for us in North America. Okay, and so to show that we have some customers in plastics, I wanted to go ahead and show this slide with some of our customers. These are people that are currently using the Opcenter APS in one or more of their facilities, and these are all people that we're actively engaged with right now. Okay, so as far as Opcenter APS and where it fits, a lot of times I get questions. People seem a little it's not clear to them, is it a standalone product or can it integrate with other systems that I have? And so the answer is yes, it could be standalone, but most people do integrate, and it's really designed to integrate easily with your ERP system. So the most typical configuration that you see is that people set up Preactor to configure it to integrate with your ERP system. So we're taking orders, bombs, routes, product information in some cases, and pulling that down to the schedule, where we're then able to work a schedule, get the best possible schedule that we can, with input from other areas of the plant as well. So it could be an MES system, could be a plant maintenance system, those types of things that we're able to pull data in from them as well, have that impact the schedule, and then pass back schedule information, dates and so forth, back up to the ERP system. And very typically how that's done. Now, as far as the product itself goes, there is this diagram, or this image, is to show that there is core APS code. There's this core code that all of the partners, even us, other partners who have been doing this for many, many years, we cannot touch that core code. Only Siemens does. They own that. But the way it becomes so configurable and the way that it can talk to so many different kinds of ERP systems and other systems is through this modeling layer that is, well, it's the way that the product is designed. So on the top left, you see we have scripting. Scripting is a part of this layer. So this would be scheduling rules, material rules that modify behavior to target, specific customer problems, basically. And you can see I've got a couple other things in there as well, but that's the idea, that we can employ scripting to get a lot of things done. As far as the user DLLs, essentially, custom code to access the API and do what we need to do to get you to where you need to be with specific requests or needs that you have. An example of that, you'll see soon, as soon as we get into software, how we can drag things from one line to another. You can drag a job from one line to another. Well, an example of that, of this, the DLLs would be where we are able to have that drag and drop automatically adjust the scrap rate on the fly. As you pull it from one to another, you can actually see the amount of scrap being modified in real time. Or to be able to do something like drag one job to another job and have them merge into one job. These are the types of customizations that we're able to do. Again, never touching that core code. As far as the top right then, where we talk about the data definition, data manipulation, all of that is done through, we're basically able to define every table, and we can add or modify tables as well. Incorporate staging tables, etc. So we do all of that there. And then finally, in the bottom right-hand corner there is the user experience, where the menus and the objects in the interface can be unique to the user who logs in. So the key takeaway from this is it's very, very configurable without ever actually doing any coding that affects the core code. So what that means is when it's time to do upgrades, and Siemens does a couple of upgrades a year, version upgrades, you just swap out that core, do a little bit of testing, and you're pretty much done. When I used to work in ERP, an ERP upgrade could take months, literally could take months. And not the case here. You know, an upgrade here with a really big full system might take half a day. So it's really pretty typical that, and sometimes less actually. So it's very, very neatly designed so that we can, you know, avoid those problems with upgrades. Okay, so I mentioned that I would talk just a little bit about planning and scheduling, and then I'll move on. And I always like to show this slide because this is terminology that's used interchangeably. Quite often people will say, well, our planners, you put together the schedule, and what they're really thinking is, well, there's planning and there's scheduling, and we make a distinction between those two different types of feature sets. Planning in our world is what are you going to make, when are you going to make it, how much, and where to make it, as well as the materials and the resources required to do that. That's the plan. Scheduling is how are you going to do it? How are you going to execute that plan? So that's in the details now, the sequencing, the synchronization, priorities, constraints, managing changes on the fly, monitoring the execution of the plan. So that's the big difference. Again, scheduling is what we're going to focus on today. Planning, if you're interested, please contact me. I'd love to talk more about that with you. Okay, so sequencing on the schedule. If you look, you know, again, when we're talking about scheduling, sequencing comes up again. Sequencing is kind of a big deal. So let's talk about that. I mean, I've heard people actually say, well, I mean, how difficult can it be? You just line things up, right? You just line them up on the machine. I mean, that's what schedulers do. It's not that big of a deal. So let's look at this. We've got 5 objects that could be combined in multiple different ways. So how many different combinations could these 5 objects be put into? How many different possible combinations are there? Give you a second, 120. So that is so you look at that and you say, well, that's one line. We've got, you know, we've got 5 different jobs on there. How many different combinations, how many different ways could that all be lined up? Well, there's 120 different ways that could be done. So looking at that and thinking about your plant and the complexity of your plant, you know, it could grow pretty fast. So let's look at another example. Now you've got the same thing only doubled. So does that mean that we have 240 combinations, something like that? What's the number? What does that come to? How does the math work out on that? The math on that works out pretty significantly to 14,400 different combinations. So now take this and extrapolate that out into your plant, to all of your lines, all of your thousands of jobs, running through all of those different lines and the possible different ways that things could be combined and sequenced. I mean, how could you ever possibly get that right with spreadsheets? Maintaining all of the proper relationships, making sure, in addition to that, that all of the constraints are being considered, the setup time, the material restrictions, the labor restrictions, the tooling restrictions, all of that. How could you ever do that with spreadsheets? That would be a pretty tall order. So there's a lot of value in APS. It does this, and it does this very well, and it does it in huge volumes. So that's what we're going to be talking about today, and we're going to now dial this in and focus it into your industry, the plastics industry. Specifically, we're going to talk about managing a schedule when you have to deal with molds, mold frames, that type of thing, temperature, sequencing, formulas, and colors, raw material availability, and labor. These are the things we're going to touch on, but along the way, you're going to get a look at the industry, you're going to get a look at the product, and you'll see just by virtue of us showing you different things, how easy it is to navigate, how visual it is, and how much information you can get simply by looking at the board. Okay, and with that, I'm going to stop talking and stop sharing, and I'm going to pass this on to Fraser.
All right, thanks, Hans. Okay, you see my screen or?
Yes, looks
We
good.
do.
You do. Okay, great. All right. Well, what I'm going to do is I'm going to walk through a Preactor. I did it. I've been calling it
Opcenter.
Preactor for 23 years. On my first sentence, I blew it.
Old habit.
So I'm going to go through an Opcenter APS model. This is a very simple model set up to demonstrate a plastics injection molding company. So before I actually get into the schedule and look there, I just want to quickly look sort of under the hood and just show you essentially how I built this model. The first thing we will always do in one of these models is simulate the production environment. So in this production environment, basically you can figure out what I'm doing here. We're mixing stuff, we're going to cure it, we're going to run it through the press, and then we're going to cool it. So very basic stuff. So I have five mix machines, 5 curing areas or machines, 5 presses, and then 5 cooling benches. So that's essentially the process that we're going to go through. And inside Preactor, we have this concept of resource groups. What a resource group allows Opcenter to do is to, quote, optimize the press, in this case, that's going to be used for a particular job. So what the actual process is when I have a job that needs to go through the presses, our system will actually check what happens if I ran it on press 1. What would happen if I ran it on press 2? And essentially, it's going to look for the earliest completion of that job. So the whole time we're scheduling anything, we're constantly looking for maximizing throughput and getting jobs done as soon as possible. Now, I've opened this model up so pretty much any press job can go onto any press. But if you have different presses that have different capabilities, we put those in their own little group, and you basically have control over what product goes where by using those kind of groups. So we have our machines, and we also have something called a secondary constraint. And a secondary constraint is not only do I need a machine to run the job, I also need something else. So that can be either people, which we have here. I have operators, cure room, press room operators, and cooling operators. They're going to be assigned to actually run jobs as a secondary constraint. And then I have a whole slew of actual mold numbers, okay? So a mold number is assigned to a particular product. Therefore, when I'm running a product that needs mold number 3 in the press, not only do I need a press, I need a press room operator, and I need the availability of mold number 3. So all that has to come together. Now we're going to simulate this as though we were pulling from an ERP system. So when we're connected to an ERP system, we're also going to bring in things like raw material supplies. So the first bunch of lines here is almost like a beginning inventory location, an inventory number for mixed A through. And then I have a series of purchase orders which have different arrival dates. So we're bringing all that stuff into the model. We have our products, we have our routings. We've got a series of orders that we're bringing down. So typically we're going to grab all the open orders or changed orders that are in our system. We're going to bring those down, and we'll walk through those in a little bit. And then I also have a bill of materials, which basically says, okay, for the mix operation, I have a required part number and it's mix number A, and I have 1.5 per quantity of what I'm making. So I've basically brought everything down from my ERP system that tells me what supplies I have, what orders I have, where they go, what the due dates are. Everything is now loaded up into our model. So typically you go here and you'd import the orders, and then the scheduler person will do that and then go into the actual generate schedule, which I'll do now. So again, here's a rehash of the orders that we've got. Here's my typical Gantt chart. You know, here's the machines that we were talking about. And I put them in the right order. So we go from mix to cure to press to cooling. Now, and then up top here, little milestones. Those are the purchase orders for raw materials that are coming in. So we'll take a look at how we could sequence these. And the very basic one, and if you're limited to just a bundled scheduler in your ERP system, you're probably looking at something like forwards by due date. So I'll actually go ahead and I'll press forwards by due date, and we'll let Opcenter lay the jobs down, and we'll talk about what we see. So if we take a look at this job here, all these sequences here, here's our KPIs down the bottom. 98% are on time, and we got 972 hours of setup time. So first of all, what is setup time? It's all these little black lines in between the actual product. And what is causing those is basically changing things like color and product family or things like that. So if I change my coloring to product color, that's a little better one. Now you can see where I have, and for example, in the mix area where my mouse is, you've got a bunch of green jobs. So they're the same product color, so I don't incur any setup time. But then I switch over to red. And behind the scenes, I have a little matrix, which basically tells me when you change product color, you incur X amount of setup time. But then I go green again. So this is one of the problems with a typical ERP bundled solution, is it doesn't have that concept of when you change some attribute, how much setup time do you incur? Now, as Preactor, Opcenter has done that. I can still move things around. So I could actually take this job and pop it up there if I wanted to. Get some annoying little messages. What those messages were is when I did my own manual change, Opcenter is looking for violations of some of the limits that I built in. Remember, I said I have secondary constraints as well as machines. Well, here is a secondary constraint: mix operators. I've only have 9 guys, and I'm not actually using any of those 9, all of the 9 guys, but I'm up here 7, 8 or so. We look down. If I look at my cure room, I had 7 or 8 people in the cure room, and I'm actually banging up against that limit the whole time. What that tells me is that this entire schedule that we're looking at is completely constrained by the number of cure room operators. And actually, I can drag a little line across, and you can see where all of these cure operators are being assigned. So if I was to move a cure job, hopefully I can get that to happen again. Yes. I moved it into essentially a bad location. My manual change has put some kind of override onto that. I basically violated the number of operators I have. So I'm going to put that back where it was. Right. So let's take one more look at click one job. If we take a look at this particular job, you can see these little connecting lines. That is basically connecting me from the mix operation to the cure operation to the press to the cooling room. And I can actually look at this also based on its raw material, the bomb exploder, the material explorer. So we can see if I go all the way to the end here. So here's my final cooling operation. It was fed by the press. I can go here and see the press operation. It was fed by cure. I go here and see the mix, and it was fed by here, and it was fed by a purchase order. So this job could not start until that particular purchase order up here was arrived. So we're keeping everything linked together based upon what potentially the MRP was run in our ERP system. Okay, so I do happen to know, if I go back here into my Material Explorer, if I look here, I've got 4 shortages. So we'll take a look at one of those. And this is basically telling me that I've asked Opcenter to run a job that requires mix X. Okay, I have no mix X defined. So I basically wanted to show that when we bring all this information from the ERP system, we can basically do a sanity check on, are all the raw materials there? I could ignore it, or I could leave it there. So it just gives you the ability to actually schedule. If you know you've got a shortage, if you say, well, that's obviously just a problem, I'm going to ignore it and schedule it anyway. So there's a lot of functionality you can do there. Now, we'll go back to our KPIs here. 98% on time, 972 hours of setup time. So what can I do to that setup time to minimize it? Basically, we'll try a different kind of schedule to do that. The first thing I'll do is take a look at one of our options called a waiting rule. Now, the first time I ran the schedule, it was purely due date driven. So it was as though I had put 100% on due date. So I want to figure out which is my main driver for all that setup time. And I'm going to use table attribute 1, which I believe, if I remember right, happens to be these product colors right here. So I'm going to try and keep the colors the same as much as possible. So I'll set the weight, and then I'll run forwards by that weight. And visually, you can already see that it is really trying to keep those colors together and minimizing setup time. And if I look at my KPI now, I'm down to 705 hours, but I'm 100% on time, almost 100%. Actually, I have 1 late job sitting out here. So that is another option that you can use to a what-if scenario. What if I schedule a different way? What if I tried this? What if I tried that? And it basically will give you that feedback as to scheduling in that way will minimize setup, or it'll make it worse, or you'll make your jobs late, whatever. So I want to see if I can do even better than that. So I can take these guys off the board, and this time I'll run a completely different rule called minimize overall setup. This one makes no differentiation in due date. All it cares about is trying to get those jobs to actually minimize setup. It doesn't matter to this rule if a job is late. It just wants to do minimizing setup. Let that guy run. It takes a little longer because it's an APS rule. And you can see my setup, look at my KPIs. My setup is down to 122 hours, massive decrease in setup time. But look at what am I causing? You know, who's paying for that? And who's paying for that is my on-time deliveries based on my job. So I've got lots and lots of late jobs. But you can kind of see what it did. It said, keep the green jobs on mix number 1 until you run out. Keep the red jobs on mix number 2 until you run out. If I actually take a look at the presses, these are basically, it's by temperature in this case. So I've got a temperature of 310 there, 310 there. You can just see by the color, it kept that press temperature the same the whole time. So under the hood where I had all these matrices that tell me what happens when you change press temperature, what happens when you change color, that matrix has basically said, well, if I do it this way, everything's 0. So almost everything comes out and you've got a serious reduction in setup time. But you have to play that back against the fact that I've got a lot of late jobs now. So that is just one of those options that you can use in the what if calculations. So at this point, I know color is a driver, but color is more important than late jobs. So I really would probably want to go back to using that weighted rule so I get my best sequence. Oops, I didn't already set weight once. I get my best sequence for sequencing, which was essentially forwards by weight using that color. And that pretty much gave me my best result, 705 hours of setup time and 100% on time. It all depends on your goals. If, you know, minimizing setup, because setup is very expensive, you'd want to use one way. If really what you're trying to do is always meet your customer due dates, you would do it another way and do it to minimize those late jobs. Let me pause and see if we have any questions.
That is excellent. And we do have some questions that have come through. We actually have 4, but I do want everyone to be aware we are 33 minutes past the hour, so we're a little over halfway through. I'm going to go ahead and get the first question out there, and these are great questions, so keep them coming. The first of which is, how do you make adjustments in Opcenter APS if you need to take a press down for maintenance?
Okay. Very good question. If we are able to, I'll do it manually. We'll take press number 1 down. Essentially, we edit the calendar on a press. Now, if you have some sort of maintenance application, any other system, an MES system that can give us that information, this can be automated, but I'll just show you essentially, if you automate it, what happens. You take the press, and we have a series of calendar states. So I actually have a breakdown state, so we'll take that one. And I'll make it big enough so that we can see it. We'll go from the 1st up to, let's try the 8th. So obviously, you know, if you're automating this stuff, it would be look a lot nicer. But you can see it dumped in this little state with a nice little brick foundation, so you can see what's actually going on. Now that you've actually put that in there, you notice that it pushed all these jobs out to the right. So if I do some validation, most likely I'm going to find stuff that's completely out of sequence. So then you would actually run one of our tools called repair schedule, which for some reason goes to my other screen. And this repair schedule will do its best to get these things back in sequence. There's one option. So it basically move things around to get yourself back in sequence. Another option would simply be, okay, well, I know that machine's gone down. Let's put a freeze zone onto our system. Let's pull everything off the board and let's run the rule again. So there's kind of 2 ways to do the fix. You can either repair schedule, which doesn't necessarily move a job onto an available machine, if the breakdown isn't too big. If it's a longer breakdown, like multiple days, you would probably want to pull all the stuff that has not started and reschedule, giving Opcenter the chance to go through that optimization of which is the best machine to run the job.
Great. Great explanation. This same attendee had a second question here, and that is, what if a mold is unavailable? And the example they gave was if it's in the shop for repair.
Sure. So basically all of the molds that we potentially have were downloaded probably from the ERP system at one point in time. So these are all the molds that are in the system. If I take a look at mold 100, for example, we can see that it's basically set to a custom value of 1. So I always have one mold. Again, you can automate this, but essentially what the change in automation does is just take this mold and set it to 0. Okay, so now I have no mold for whatever job uses that. And if that job is in here somewhere, we actually used it. There we go. I chose a good one. We violated the fact that a mold 100. So I had a job in here that was scheduled to use the mold, but now that mold is unavailable. So if I run the schedule repair right now, I would hope, I think it does, it would pull that job off the board. So if I actually look at my editor, I should see a job. I'll probably never find it, but somewhere in here is a job that's no longer scheduled on the board. There it is. So one of those jobs right there, all 3 of them, are using mold 100s. So therefore, I'm not allowed to actually schedule, so they'd be pulled off the board. So again, if we have a system that can feed us that information, we can automate that with every download or every update that you want. But what I just did there manually is essentially what ends up happening.
Great. Great. And while we're on the topic of mold, there's another mold question, and that is, does it handle different molds with different number of cavities?
Yes.
And will it change the run rate?
Okay. Yes. Good question. If we look at my sequence here, I actually have the number of cavities per mold. So if you look here, there's 1 cavity, so it's big mold. We're making 6. Our requested quantity is 1608. I've got 1 cavity, therefore the press quantity is still going to be 1608. So 1 press stroke for each product. So that one doesn't change. Here, I have number of cavities of 4. So my original order quantity was 2412. I got 4 coming out, so my actual press quantity is 603 press strokes. And the time essentially doesn't have to change because all I've done now is I've changed my actual press stroke quantity. So it's the actual time. If this was a one cavity job, that may take 4 hours. But now I've cut that down with the number of stress strokes. It's going to take 1 hour. So it does in effect change the run speed, the run quantity.
Very good. And there's one last question here before we move on, and that is, can I change molds on the fly?
Right. My particular model.
You know, I could.
Yeah, my particular model does not show that, but I know that Hans's model does have that. So.
Yeah, I do, and I could use that as a segue. If you're done, Fraser, I could just go in and go ahead and step into mine.
I'll stop share. It's up to you.
Excellent.
All right.
And these are great questions. So please keep coming at us with more questions. Thank you.
Okay. So before I just jump to it and show it, I do want to do real quickly just a little bit here to show you a little bit of setup, because this is a different model. Whereas, for instance, in Fraser's model, he is set up with multiple steps per operation, whereas my model, every job is a single operation. So it's a different kind of plastics manufacturing that we're doing, but we're still dealing with the same thing with molds and so forth. So when I look at a couple things here that I just want to share with you is we have groups of molds, and in this case we're looking at the molds as being within a frame, and that determines the number of cavities that we can have within that frame. So to start with, then, with mold frame groups, with the groups that we have, we're basically very similar to what Fraser showed earlier with his resources and resource groups. We're able to do the same thing with these molds and put them into a group that of molds that are similar that could be swapped out to do the same product. The difference in these is that in all of these different molds is, any given one that we open up, we see that there's an attribute where we're seeing the number of cavities. Similar to what Fraser showed you earlier. We've got a mold, and it's got the number of cavities, and then what would the number of impressions on the press be based on that. So that is built into all of these molds, and then they go into those mold groups together, and then can be called on by the schedule, and there's some other things that we can do with that. So I wanted to show that before I went ahead and opened the schedule, and we'll take a look at this, and you can see how dynamically, and back to your question, we can see how dynamically it all, how it all works. So similar look to what Fraser was showing you. We've got, I've got my, I'm able to identify where the different groups are. and I'm able to identify different colors as well, material types. In fact, lots of different things, lots and lots of different things that we could put in here. And it really just comes down to, well, what is it that you want to see? What is it that you need to use to be able to colorize the board in that way? But specifically to the question that you had, I want to focus on, I'll just pick this job. It's an easy one at the top right. So when I go ahead and open this up and look at a couple things here. So we have what's called Makespan, which is the beginning from when the setup starts to when the job ends. In this case, it's 5 days, 18 hours, 20 minutes. And when I look at the mold frame attributes in here, what I'm able to see is that we're using a mold that has 32 cavities. So we've got a mold frame group up here, as I showed you before, and within that mold frame group, we have all of these molds. All of these molds exist in that group. So I can come here and just really using the scroll wheel on my mouse, I'm able to scroll through to different mold frames. If I know the one that I want to find, I can find it by its number. Or if I'm just looking for something with a larger number of cavities, for instance. So I just grabbed one that has 48 cavities, and I go ahead and close that, and you can see the immediate impact of what happened when I added that in. So we now reduced the number of impressions that need to occur, and therefore the amount of time it needs to get through the press. And when we look at the make span on this now, it's closer to 3 days than the 6 days there where it was before. So I know that was a long, windy answer to your question, but basically you're able to do it if you're set up in this way to be able to select a different mold, do it on the fly, and have it dynamically react to it right on the floor or right on the schedule as you're working with it.
That's perfect.
Okay, good deal. I actually didn't have a whole lot else to share. I think Fraser covered most of what I would have been able to share here. So I think honestly, if we have more questions, Chris, yep, we can go ahead and take them.
We did. We had two others come in. The first of which is, how do you update a job to tell if it's running or behind schedule? Okay.
So if you have an MES system, shop floor data collection system, we can integrate to that, and it can go ahead and feed the schedule in regular updates. If you don't have an MES system and you're looking for one, we have a small one that we've done that plugs in. It's kind of a Preactor plug-in, if you will, is what we call it that anyway. And it's a shop floor data collection that we call Track It. But whether it's the Track It system or whether it's a regular MES system, the bottom line is that it comes into, not the operation times, my bad, the operation status. We have what's called a mid-batch quantity. So essentially what happens is we're being fed from the shop floor. How many pieces did you produce? What was the quantity the quantity that you've already produced? It feeds that in here. And then once we have a quantity that we've produced in here, then it will give you a visual indicator. It will draw a line through the bar, and you're able to see how much of that job has actually been produced. So that's essentially how that works. And I'm just thinking I could probably put a mid-batch quantity in here of, I'll just say, 75, something like that, and say okay to that. And then you really can't see it in this example, but it will put a bar in there, and you're able to see a visual indicator of how much of it has been produced. Also, I should point out as well, if you were expected to, let's say the job is for 8 hours, and you were expected to do 100 in 8 hours, but you only got 20 done, you're at 4 hours and you've only done 20. When it gets that update, it will extend the remainder of the time out based on the fact that it thinks you're now working at a slower rate. And so it will extend the amount of time that it's anticipating it's going to take to complete the rest of that job. So it's very dynamic in the way that it reacts, or the way that it interacts with shop floor data collection and updates. Okay?
Excellent. Excellent. Well, we'll throw another question at you here, Hans. It's, how does implementation work? Do we do this ourselves or work with LSI?
Okay. I'm going to say it's a combination, to be honest with you. We have a full implementation plan If I'd been on my toes, I would have had it up on a slide that I could have popped up and talked about. But we do basically have an implementation plan that we do over and over and over again, that it starts with assessments and design work, discovery, assessments, and design, where we determine exactly what your needs are. And then we work through a process of, once the design is set and everyone agrees that that design is comprehensive and that it works, we have that design. Along with that design, we develop a project plan. And in that project plan, we determine how much of it are we going to do and how much of it are you going to do. Now, we have it all worked out as to what it's going to take if we do the majority of the work. And you're always going to have to do some, because you own the data, you need to be trained, it's your system. So you're going to be involved, there's no doubt about it. But if you're technically capable and able to do even more work above and beyond just getting trained and working, then we allow you to do more work, which reduces the cost of implementation to you. So we have these series of processes that we go through, from design to configuration, design, integration, configuration, testing, a conference room pilot, go live. And we always attempt to get you to 80% of where you need to be as quickly as possible. So it's kind of the 80-20 rule that we try to follow. We want to get you 80% of the way there so that you're up, you're running, you're crushing those problems that brought you to us in the first place. And then that remaining 20% is refinement and tweaking and determining, are there additional things that you would benefit from that we can provide for you? Then great, let's do another little, a small mini project to follow up and work through that and get that implemented as well. So it's a process, but again, I want to emphasize, we want to get you 80% of the way there in the quickest possible time so that you realize the benefit of this right away. So we can talk more about our implementation strategies and so forth, happy to, but that's a pretty high level description of it.
Fantastic. No, that's great. And that was the last question that we had for today. And the two of you did a fantastic job. You took 60 minutes worth of material and you did it in 50. So looks like we're going to finish a little early today. Did you have anything else, either of you, before we put up our contact information there?
Yeah, go ahead, Fraser.
No, I say I don't have anything extra.
You don't, okay. And I really don't either, other than to say, we love your inquiries. Don't be shy.
Yeah.
We're not going to badger you. We're not predatory marketers who are going to come after you or anything like that. But we would like to, have the opportunity to talk to you about your business and to show you, do some demos, do a little discovery, learn what you need, and let us give you a presentation that focuses on those problems that we learned from you. And you can see, just in a demo, there's no cost to you, to see what we're going to be able to do. It can give you the vision, give you the idea of how we can address your problems, and then from there we have multiple options for how we can proceed. So that's all I wanted to say about our process. Thank you for coming today. We really appreciate it.
Yes, and if you do, if you're looking for more information, absolutely, you see our contact information there. And I want to encourage you to go check out our website at lean-scheduling.com. There is a wealth of material on there, videos, articles, as well as on our YouTube channel. If you want to see more of the product, and as Hans said, we're more than happy to give you a demo. Thank you all for joining us today. We certainly hope that you've been able to take away some valuable insight and information about the ways that Opcenter APS can benefit those of you in plastics. We're going to leave this screen up for another minute or so, but we'd love the opportunity to learn more about you and provide you with any additional information that you may need. I sincerely hope that you have a great rest of your day and your week, and we look forward to hearing from you. Thank you.
Thank you.